Hey everybody, this is your 5.1 pre-calculus composite functions video. So when we talk about composite functions, we talk about f of g of x, which is the same thing as f circle g, and we talk about g of f of x, which would be g circle f. In previous lessons, our study of functions concentrated on polynomial and rational functions, which are algebraic because they can be expressed in terms of sums, differences, products, quotients, powers, or even roots. Functions that are not algebraic are called transcendental. And so this is the first one that we're going to be studying, which is exponential, and then after that logarithmic. So it's called transcendental because it transcends algebra. Even though it's a part of algebra 2, it's beyond the basic algebra. So exponential is going to be one where x is the exponent and it grows or decays fast. And then logarithmic would be slow growth, like square root of x. So those functions do occur frequently in a wide variety of applications, such as biology, chemistry, economics, and psychology. The chapter begins pretty basic with composite, one-to-one, and inverse functions, because that is the relationship between these two, which are inverses. So consider the function or the situation where you're going to need to understand the function. You're ready to buy that first car. You know that cars lose value over time due to depreciation, and the different cars have different rates of depreciation. So you can research the depreciation rates for the cars you're thinking of buying. After all, the lower the depreciation is, the more the car will be worth each year. So basically, like after any purchase of a vehicle, right when you drive off the lot, it's gonna like lose value a little bit. It's kind of ridiculous actually, but houses appreciate, which means they grow in value, and cars and other vehicles depreciate, which means they lose value. So you could think when they get older, cars break down much faster than houses, because on houses you can renovate. But these, like, they get old and need more maintenance. So anyway, that's just a side discussion. But to get into this lesson, you need to find the value of a function, the domain, which are basically the x's, form a composite function, and find the domain of the composite. So first, about the forming a composite function. Suppose f and g are your functions, and that x is a number in the domain of g. You do g of x because you're basically going to work inside out, and then once you have that answer, then you plug it into f. So only the values that are in the domain of G work. So in other words, if it's undefined in G, then you can't do f of g of x either. If it's undefined in G, then also undefined on f circle G. So again, we'll get into specifics in a minute, but you do work inside out. So when we talk about evaluating, you're going to have to substitute numbers in. And normally the value for f circle G is not the same as the G circle f. When we talk about the domain of the function, you'll have to form it and combine your like terms. And if it's linear and quadratic, then the domain is all real numbers because there's no break in it. If it's rational, then that's like what we just covered, where the denominator would need to be set equal to 0. So if it is just 1 over x, it's going to be all reals with x not 0. And if it's a square root, then the function would look like this, where you can't have negative answers, but the square root of 0 is 0, the square root of 1 is 1, but then the square root of 4 is 2. So that domain is 0, infinity, like that. And we'll get into more with the reciprocal also. So that's when you have to set your denominator equal to 0. If it does have bars around it like that, then it's called absolute value. And because that graph looks like this, it'd be all real numbers, and your range would be y greater than or equal to 0, which is the same as 0, infinity. So keep the following two thoughts in mind. Any x that's not in the domain of G has to be excluded, and any x which is not in the domain of F has to be excluded. So now, generally speaking, if both are linear, then you're going to have all real numbers for both the F circle G and G circle F. If it's quadratic for one and linear for the other, you're still going to have all reals. If it's absolute value and if it's quadratic, again, those are all reals, but it gets tricky when you have a square root function for one of them or both of them. And also when you do a rational function with the 1 over x. So now we're going to generally talk about a composition function. Composite means put it together. So it's going to sort of look like a piecewise function, but it's going to be f of x with g of x. You're also going to show that two are equal by getting x. And if it is just x, then it's the inverse. If it's anything other than x, that's not the inverse. And pay attention to your order of operations. If there's multiplication in one of them, there's going to be division in the other because they're kind of like opposites. And if there's subtraction in one, there's going to be addition in the other. Now, the other thing is they are going to reflect across y equal x. So this simple example says 3x. So then you switch x and y and solve, and you get g is 1/3 x. So this is multiplying by 3. This is dividing by 3. So then about finding the components of it, You're going to have some expression that kind of looks like that, for example, and you're going to say something to the third power is going to be the g function, and then the inside is going to be the f function. Okay, so there's our important concepts. Okay, now getting to the problems themselves. This says f circle g of 1. So we're doing g of 1 first, and so we go to where x is 1 and go to g. So this is the answer where you get 0. So the g of x part, like this is your x basically, and you get the result 0, and that's the inside part, and now you do the f part. So you do f of that answer and go to 0, go to f, and that's this one, -1. On this one, you go to g of -1 first. So go to -1, go to g, and that's 0, and then do f of 0. So that's -1. This one you do f of -1 first, and that's -2. Then you do g of -2. So go to -2, go to g, and you get 3. It is important that you master this concept because in calculus, they do it with h also. You're going to have 3 functions. Now for this one, we do f of 0 first. Go to 0, go to f. It's -1. Then do g of -1, and you get 0. And then for this one, g of -2. So you go to -2, go to g, and you get 3. And then we want g of 3. So go to 3, go to g, and we get 9. Okay, and then for this one, you do f of -1. So -1, the f is -2. Because that's the ordered pair, -1, -2, basically. And then you do f of -2. And go to -2, go to f, and you get -3. Because that's the ordered pair, -2, -3. Okay, so that's the one with a bunch of numbers that are just in a table. You also have ones where they don't actually tell you the function itself, other than just saying f of x and g of x. But what you do is you kind of like use the ordered pairs. So this one says f of -1. So you go to -1, go to f. So f is the lower function, and g is the upper. So go to -1, go to f, and you get 1. And then you want g of 1. So you go to 1, go to g, which is way up here, and that's where you get 5. And then you want f of 0, which is 0, and then do g of 0, which is up here, which is 6. And on this one, you do g of -1 first. So you go to -1, go to up to g, and you get 1. And then you want f of 1. So go to 1, go to f, and it's, hold on, g of -1. So -1, go up to that. I just did f on accident. That's my bad. So I got 4. And then we want f of 4, which would be 0. Because that's the ordered pair 4, 0. And on this one, we do g of 4. So we go to 4, go to g, which is 3. And then we do f of 3, and that's -1. So that's basically how those work. I know you'll need to go on your own pace at that, but the idea is do the insides first, get an answer, and then put that answer into the next function. Okay. All right, on this one, we're doing g of 4 first. And so that's going to be 7 minus 1/2 times 4 squared. Seven minus 1/2. I'm going to just type 0.5 for that. Times 4 squared gives me -1. And then you do f of that answer. So again, just bring it down. And -1 is here, so you do 2 parentheses, -1 squared minus 1. Those parentheses are very important whenever it's squaring a negative number. So here that would be like 2 times 1 minus 1, which is just 1. Okay, on this one we do f of 2, and so you go to the f function, 2 times 2 squared minus 1, that's 8 minus 1, which is 7, and then we do g of 7, which would be 7 minus 1/2 times 7 squared, and that would probably just want to use the calculator. 7 minus 0.5 times 7 squared, and that says -17.5, and they might want that as a fraction, which is your -35/2. In general, the math programs want fractions. Okay, on this one you're doing f of 1, and so that's going to be 2 times 1 squared minus 1, which is 1, and then f of that answer again, and we already know it's 1, so that's how you get 1. Alright, on this one we're doing g of 0, and so we do 7 minus 0 basically is 7, and then we want to do g of 7, which would be 7 minus 1/2 times 7 squared, which is the same thing I thought we did earlier. Yeah, and so we get -35/2. Okay, now on these you're doing g of 4 first. And so you're doing 2 times 4, which is 8, and then you're doing f of 8, so that'd be 2 square root of 8. Now, the tricky part about square root of 8 is that could be written as square root of 4 times square root of 2, which is 2 square root of 2. So then we have 2 times 2 square root of 2, which is 4 square root of 2. Okay, so resuming with this, what we did was the first one, which was g of 4. So you go to your g function, 2 times 4 is 8. And then you take that answer, plug it into the f. So f of 8 would be 2 times the square root of 8. And this is where the calculators differ a little bit. You should be able to get to this point yourself by saying square root of 4 times square root of 2 and 2 square root of 2. But just so y'all see what's going on, there are calculators like this blue one where you can say square root of 8 and press enter, and it simplifies it for you. Now the blue and white ones don't do that. The blue and white ones do this. Well, this one's square root of 8, enter. It tells me a decimal. So both of them say CX2, but this one has the CAS operating system and it's newer basically. So this is pretty equivalent to the teacher calculator on some things, because mine would also do the same thing. If I did square root of 8, enter, I get 2 square root of 2. Anyway, that's just a little side discussion. Okay, but you should be able to break it down. 8 is 4 times 2, and then this is 2 times 2. You have a pair of 2's, and then the leftover goes underneath the square root of 2. So that's how that works out. Okay, on this one we're doing f of 2, so we go f of 2 is 2 times the square root of 2, and then we do g of that answer, and that's going to be 2 times that answer, and so that's 4 square root of 2. So we do get the exact same thing as the previous answer in this problem for these numbers. Now on this one we're doing f of 1, so we do f of 1, which is 2 square root of 1, which really is just 2, and then we do f of 2, which would be 2 square root of 2, and that's our answer. And then the last one's easy because g of 0 has to be 0, because 2 times 0 is 0, and then you just do it again, which is stupid, but g of 0 still is 0. Okay, moving on to this one. Now this is where it gets a little weird, because you have a fraction, so a rational one, and a cube root function. The others were linear, so that was easier. So on this one you're doing g of 4, so you plug in g of 4 to be the third root of 4, cube root of 4. Remember, in this case we don't want a decimal or anything, but if you were to type it, you'd want to go to the calculate screen and do this little thing called n to the x. So like if I do the third root of 27, that really is 3, because it's 3 to the third power. That's how it's all related. But in my case I'm doing the third root of 4, which won't simplify. It shows me a decimal, and we don't want decimals. So we just left it as the cube root of 4, and now we need to do f of that answer. So that'd be 9 over something plus 7, and then just plug this in right there. So all this does is it involves substitution. And these are not like terms. The square root, or actually cube root part, does not extend. It's just like that. Now in this problem we're doing f of 2 first, which would be 9 over 2 plus 7, which is 9 over 9, which is 1. And then we want g of that answer, so that'd be the cube root of 1, which is 1. Because 1 times 1 times 1 is 1. Okay, this time we're doing f of 1. So that's going to be 9 over 1 plus 7, which is 9 over 8. And then we do f of that answer. And so this is going to look very different or weird. It's going to look like that. Now, there is a way to do this by hand. I guess I'll show you first, because this is a skill you're going to have for when some of this is x in your denominator. And it would basically be make this 7 turn into a common denominator of 8. And so then you do 7 times 8 is 56, like so. So that's the equivalent. And then you go 9 over 9 plus 56 is 63, right? Oh, 65, I mean. 65 over 8. And then you can act like this is divide by 1 and multiply your outsides and you get 72 and your insides and you get 65. So that's the way to like really learn how to do it. Now, can you do it a different way? Yeah. Do 9 divide by parentheses 9/8 plus 7, enter 72/65. So even on this blue and white calculator, it does reduce the fraction for you without getting this common denominator and then multiplying your extremes and means. Know what I mean? So then here we're doing g of 0, which would be the cube root of 0, which is 0. And then again, g of that answer, which would also be 0. Okay, now for this one, so that was a lot of problems with numbers. Now we're doing domains and the composites. So when we're doing f circle g, you start to write f first and then substitute g. So for example, we do 7 over something minus 2. You could put parentheses there or leave it blank or put an underline. I don't actually like the underline because you may think it's a fraction. I kind of like the parentheses best. And then we have to do this expression 9 over x right there. And so this would be 7 over 9 over x minus 2. Or if you want to start getting fancy, because you are going to have to know how to do this eventually, this would be 9 minus 2x all over x. And then we could say it's over 1, so then this is 7x over 9 minus 2x. Those really are the math rules for how you do it. Now, what are we doing though? We're doing domain, and so we don't really need that. All we need is to use the calculator and put that into F1. Then find where our asymptotes are. Seven over parentheses 9 over x minus 2. So if I go to this, getting closer and closer to 0, actually closer and closer to -2, I think. Let's find out. If I start my table at 1,000, okay, we're close and closer to -3.5. Now, let's think about why that would be. I'm not really surprised. what you do is if you have 7 over 9 over x minus 2, this part right there is what gives you your negative 7/2, or negative 3.5. So that's your horizontal asymptote part. And then, like we said in the notes before, if you're doing your domain of each of these, the F domain would be all reals x naught 2. The G domain would be all reals x naught 0 because of that. But since we're doing F circle G, we have to say this is from the G domain and this is from the F circle G domain. And let's find out. Okay, so if we put 9/2, which is 4.5 in here, go to table, settings. If we put 9/2, going by a half, 9/2, which is 4.5, is undefined. So now you can see my step is changed to a half. So that's one way to do it. That may not be your preferable way. The other way to do it, though, is if we have this part right here with 9 minus 2x, set that equal to 0. And so if you subtract 9, you get negative 2x equal negative 9, and then divide by negative 2, so x is 9/2. So that really did help you get to here. So that is a good skill to have as well, because I don't know how you can actually do that one without that. I'll try one more time. 7 over parentheses 9 over x minus 2 . If I'm just thinking through it, okay, if I do tab, change this to a relation, and say x equal 4. See, 4, when I move this up to like 100, it crosses it. But if I were to change this to x equal 5, this method is not exact, by the way, but if I change it to 5, it's too far away, if you could imagine that. And then if I did it as 4.5 or 9/2, that's exactly what we want. So that is another method. Now, that is not my method, but if you want to try it that way, you can. I really do prefer just setting your denominator equal to 0. That's probably a good stopping point for that video, and then I'll make the next video.